Hello and welcome to 5 Minute Math. Today we are looking at some activities to help teach the standard Algebra 1 2I writing systems of two linear equations given a table of values, a graph, and a verbal description. So this is all from my a blog post on my website, 5minutemath.net. I'll put a link to this in the description of the video. So to start with, at the top of the blog post, you will see some of my teaching videos explaining how to write systems of equations from graphs, systems of equations from tables, and of course, systems of equations from verbal descriptions. Now, the reason why I'm wanting to share these activities is because on the most recent STAR test, state of Texas did not do too well. We had 39% get this correct, and this was a multiple choice, wasn't a new item type. We literally just had to take these tables and create two systems of equations, not even find the solution, just generate equations here. You notice we're in standard form, and only 39% of our students got this correct. Here's the explanation of how to solve that particular problem. The activities here follow a framework. Active playful learning is an idea that is starting to come out and is starting to be researched across the country about what makes students more meaningfully engaged, and that's when they are active, that they're social, they're iterative. In other words, Star Prep does not need to be mindless worksheets, does not need to be boring drill and kill. We can have fun, and all of the activities that you're going to find here are lots of fun, and you can have fun in algebra class. So when I'm done with this video, that link is going to be right here. But let's look at our 5 activities. The first one is called Prove It. Now, the objective here, students are going to use a table of values to simply write a linear equation and then use substitution to check its validity. This only looks at a single linear equation, but these skills are needed when you are working on a system of equations from a table of values. So the idea here is that we give students a table of values, at least 4 pairs of coordinates that lie along the graph of a linear equation. So here's an example, right? You've got a simple table here. You got x and y coordinates, but we want them to do specific things. We want them to first use the formula for slope that we see right here, using 3 different combinations of x and y coordinates. Each correct solution is worth 1 point. So you see I use the first pair, right? And the second pair, 18 and 3, and then -9 and -4. And then I did the 18 again, but then I used this third pair right here, and then 18 again. I just kept the same first pair, and then I used this last pair as my x sub 1 and y sub 1. So you could do that multiple ways, but you want to do that at least 3 different times to really drill in that idea that it doesn't matter which order or which x and y coordinates you use. Then you want them to use the point slope formula to find the equation in the slope-intercept form using 3 combinations again. So now that we know that our slope is -3, I need to use 3 different sets of x and y coordinates. So I use the first one, I use the second one, and I use this third one here to all show that my slope-intercept form is going to end up at that y equals -3x minus 9. Then I want to use all 4 coordinate pairs in substitution to verify. So now I've got my slope-intercept form, right? And I'm just going to plug in each x and y to verify to make sure it's correct. The point here is that we want students to be so familiar on how to take a table of values, turn it into a linear equation, that when they're asked, like in the STAR test, to create 2 linear equations, it's easy. And they know how to use substitution to prove their answer. So that's just an example of what we did here. Now, we've got some variations. You can provide a larger table of values, right? My table of values only had 4 points. You can provide 5 points, 6 points, whatever. If there's one step of the process, like the point slope formula, that is more challenging, increase its relative score, make it more points, or say they have to do more of that, right? There's some point in that process that students need to possibly focus on. Now, in the table, you can also generate 3 extra columns, right? So I can just add 3 columns here, and then they have to, once they find the correct formula in the slope-intercept form, they have to generate 3 new x and y values that match. And then finally, you can have students graph a line and on a graphing calculator or online graphing tool, and then use that just to verify the accuracy of what they did. So that's our first activity. Our second activity is called real life systems of equations. This really goes to that verbal description because sometimes students have a hard time understanding how to generate real life system equations or even recognizing it because there's a lot of word problems there. Sometimes they, in Algebra 1, they have to use exponential functions, quadratic functions, all of those from real life verbal descriptions, and identifying what they need to do can be difficult. So here are some examples of real life systems of equations. And what you're going to notice here is all of the numbers are in brackets. And I just did that to kind of call them out. All of these work, but if you ever wanted to use these as exemplars and simply change the values, you can do that. So a real life system of equations for business sales, cell phone plans, distance and speed, investment returns. This is a little bit tricky because we're going to need to turn these percents into decimals, earning allowance, concert tickets, two different types of tickets, general admission and VIP tickets, right? So you get some real life examples. Feel free to use those. Have them solve three of the problems, writing the system of equations that represents scenarios, and then after the majority of the class has written the system of equations for three problems, just 3 out of 6, right, in that particular example, ask students to check only one problem, check their work with a partner, but they have to hit at least 3 different partners to check their work. So it's, you get up and you get to move a little bit, and they increase their activity and their communication. So we're just practicing, but there's a social element there. Now, what are some variations? Use a graphing tool, have students graph the system of equations and plot the solution. You can have them create tables, which, right, none of this here has any tables. You're just writing systems of equations, but maybe you want to have them generate tables to represent several points along the graph. Have students manipulate the constants, right? Those are the brackets, utilizing the same scenario but different numbers. Then they solve those, but they want to make sure that the numbers are fairly reasonable. We don't need a whole bunch of, decimals. It'd be great if we had integers. And then using those examples as a starting point, have students generate their own problem scenarios. So maybe something like that, but they use that as an exemplar. So this really helps because if you give, rather than choosing all 6, right, this gives students a little bit of choice. They get to choose the 3 that they want, and then they get to choose who they want to check their work with. So that's our second activity. The third one is called table race. So we're going back to the table of values, but we're adding a little bit of low stakes competition here. So you want to put students into groups of 3, right? And then you either want to display or print out 10 tables and 10 matching equations in random order. So what I have here, I have, if you want some table of values, I've got 10 of them that work here. These all are from released start items. And I have the correct equation underneath here in standard form. When you display them, right, what you want to do is you want to have the 10 tables up. You want to have the 10 equations up, but obviously you don't want them in the exact same order because they'll figure out real quick, oh, the third table goes with the third equation. Mix those up. Once you have that, you literally display all 10 equations, all 10 tables. Maybe they're on the board. Maybe you have them on a piece of paper randomized. And then in the teams, right, they just have to match the 10 tables with the 10 equations and see who can get it done first. And then ask students afterwards to share the strategies. Maybe they're writing the equations in slope-intercept form. Maybe they're not. Maybe they're just using substitution, right? If I were to look at this first one, I would look at, ooh, y equals 0. So anything that's got a 0 or a 1 is easy pickings. So I would pick anything that has an x or a y value of 0, and then I would start with that and just start substituting. Maybe they do that rather than finding, the slope and using the point slope form. But it just adds that little key of that little low key competition. Students can work in groups, they can work together, and that's all we're doing. Now, a lot of variations here. If you want, you can start with just 5 tables and 5 equations. Then after that, you do a little bit of a class debrief, let the kids share their strategies. Maybe some kids weren't necessarily just using substitution. Maybe they were trying to derive the slope in the point slope form. So highlight the different ways they can match tables and then give them the next 5 and then allow them to try out the new strategies, right? If you want to really change things up, give them the same 10, but maybe change half of the equations to slope-intercept form. So just visually, they have to go back and forth between point slope or the standard form and the slope-intercept form. Now, to raise the difficulty, withhold the equations for about maybe 5 minutes or so. Let them first start with just the 10 table of values. So they have to use the equation for slope, the formula for slope and point slope in order to find a few equations. Then give them the equations afterwards and they can either match them up, or if they're still stuck on a few, they can start using substitution. And then if you really wanted to make it difficult, use the same, the same tables, right? But you want to change all the x values to be the same. 1, 2, 3, 2, 3, 4, right? And maybe you want to make it 4, 5, 6. You really eliminate those easy x of 1 or x of 0, okay? Now, our next strategy is called graph to equation foursquare. And so really we want to take once again, this activity focuses on a singular linear equation, but if we can figure this one out, we can easily write a system of equations, right? So what we want to do is we want students in groups of 4. Now here's an example, okay? So this is an example here. In each group of 4, each kid has a different graph because each kid needs their own paper in front of them. So this is just one. You're going to hand each kid a different graph. And if you got groups of 4, you only need 4 different sets, one for each first, second, third, and fourth kid at a table. So you would need 4 sets for the class, multiple copies. So the first kid is going to get possibly this one right here. And then what they do is they're going to use that graph and they're going to generate at least 3 coordinate pairs, just basically just looking at this graph. So we're going to print this out and they're going to write some x and y coordinates there. Then you rotate, okay? Every kid passes their paper in the foursquare, one person clockwise, and then that new student, right, is going to use the graph, use the table of values to now find the slope of this equation. So everyone does that on a new piece of paper. Then everyone rotates again. So now you're on your third piece of paper, and that third child, right, is going to use the table of values, the graph, and the slope to use the point slope formula in order to write this equation in slope intercept form, right? So now we're on our third student. And then we want that student to also rewrite it in standard form. So they can write it in standard form, and I'll show you an example of it completed right down here. You scroll down. There's this particular example, right? But there's the table of values. There's the slope. There's the point slope used to find the slope intercept form, and then I wanted to write it in standard form. So that final rotation is to go back to the original students. And then what they do is they simply check the work. They check to make sure that the table of values is correct, the slope is fine, the slope intercept form is fine, and then the standard form is fine. So there's that example. What are some variations? For smaller groups, right, you can just put the students into trios, and then that third member can write the slope intercept form and the standard form before rotating back to the original owner. If you want some additional scaffolding, sometimes these are just images exported from Desmos. Sometimes it's very hard to find the point, so you can, highlight some points there, just so it's a little bit easier to find the XY coordinates. And then if you wanted to add difficulty, what you can do is you can have students mark out the X and Y values on the table used to find the slope. So let's say to find the slope, what did I use? I used the 1 and the 2, right? And then the 7 and the 4. So I used these 4 coordinates. So I would mark these out as I'm using the slope. So the next student that has to use x and y values would have to use the 0 and the 5, which is what I did here. You don't have to do that. Obviously, you can plug back in a 1 or 2 or something, but just in order to use all the 3 different points, you can do that to kind of raise the difficulty level. All right, so our next strategy is called interactive systems of equations. We're going to use an online graphing tool. Obviously, I like Desmos. And we're simply going to manipulate. Okay, now we need to enter 2 different equations, y equals mx plus b and y equals ax plus c. So let me do a live demo here. Watch what happens when I type this in, because students need to do this, mx plus b. You notice it's going to hover and it's going to say add the slider. You want the sliders. Now you can't do y equals mx plus b because I've already used that. So I said y equals ax plus c. I said zx plus c, but we can do ax plus c. And you want two different sliders. Now, obviously, I've got two different lines sitting on top of each other. And so what we're going to do is we've got a system of equations, and we're simply going to use these sliders to manipulate them. And then what you want to do is you want to give them a challenge, right? So generate a system of equations whose solution, right, that's where they intersect, is going to be at the point 1, comma 0. Okay, so then we need to simply, we need to change these so that it looks like, all right, so that looks like that's 1. Then I want to change this so it looks like right there. All right, so I've got a system of equations that's 1, comma 0. But now what I need to do is I need to write that down. So here's my digital recording sheet. What you can do if you want to export it, right? You just hit this little share graph, and it's going to give you right here, and you can simply download it as a PNG. And so you can get that going. And then also what we need to do while we're waiting for that, we also need to type in a table of values. Now, there's an easy way to do that. If I go back into my Desmos, right, there's my export image, right, and then it would just download it and you could import it into the Google Sheet. If I click on the actual function itself, and then I hit that edit list, look, it gives me a table of values. Okay, so I could do that for both. So if I wanted to hit that table of values for both, I could use that to fill in right there. Then I would need to write each of these in slope-intercept form. This doesn't give it to me in slope-intercept form, but I would need y equals mx plus b. So y equals 2.6x, and then my b is minus 2.6. So minus 2.6. Then I would write the same thing down here. Y equals negative 1.1x plus 1.1. Okay, so I would write that down here. And then I could also convert those both to standard form. That's my digital recording sheet. Here's a blank copy if you want to simply to use this. And that's all we're doing. We're simply letting students manipulate, and that was simply to meet the requirement of find the system of equations whose solution is at x value 1, y value 0. You can also say, generate a system of equations whose solution is in quadrant 3, right? Or whose solution is in the y-axis. The point is you want them to write everything down here. So if I wanted to, if I wanted to export this, right, you download the PNG, and then what you need to do is you need to go back in here into that, and you would want to insert image, you'd want to upload it, and that's it. That's the one I just did. Now, if I want to do the table of values, I would need to copy the values from over here, and I'm just going to have to hand type them in here. And that's what we would do here. Now, what are some variations? We can, yeah, obviously, we can show them how to generate the table of values. If you don't want to, don't show them that. Make them just visually look at it. But it is a little bit tricky sometimes on Desmos. You can give them general guidelines for the slope. I just needed the two equations to hit at a certain point for a solution I was looking for. But maybe you can say one slope has to be negative, one slope has to be positive. Or you need to generate a system of equations, and the solution has a y value less than negative 5, right? So you might want to give the students two slopes, like one has to be 1.6, one has to be negative 9, and then they manipulate the y-intercept to meet the challenge. And then obviously you don't have to do slope-intercept form. You can have them generate equations in Desmos and in our standard form, ax plus by equals c. So those are the different equations that we could use here, standard form and slope-intercept form. And those are all the different strategies and activities we can use to help teach Algebra 1 Standard 2I.